So I was introduced, I'm from Japan. But actually, this is my third time to coming to Austria within a year. I came on September to attend Als Electronica in Linz. I also had a like guest lecture at Innsbruck in December. So I now really know that there's no kangaroo in this country. And yeah, I'm really happy to be here in Vienna too. So for past decade, I've been working on this project. It's a bionic arm. Bionic arm is an artificial hand for people who lost it or who doesn't have from birth. And let me introduce a little bit about my personal history first. So I was born in 1986, left-handed. I don't know what's the standard in Europe, but in Japan or most of the Asian country, left-handed is minority. So I myself felt, a little bit of physically challenged because all the equipment around me, like from scissors, there's a gate in the subway station in Tokyo, but always you have to put on the right hand. So born as left-handed, I also kind of, share the feeling of being physically disabled. And technically, I joined University of Tokyo in 2005 and have a master's degree from them. So I learned the basic technology in University of Tokyo. And I also did 1 year study at UC Berkeley. I did some brain-machine interface research. It's the really invasive ones. And then I realized I could, there's another step for designing this kind of hardware project. So I went to Sony first, and then I founded my startup company called IXI in 2014. And together with this startup company, for-profit company, I also joined a nonprofit organization called Mission Arm Japan. So this is the brief outline of my biography. So let me talk about how this technology works first. So this is how you guys actually move hands. So first thing is inside your brain. You think, I want to close my hand, open your hand, and then the motor neuron sends the electrical signals to the muscles inside your forearm. And then finally, this muscle contracts and makes hand move. And it's simple for open and close, but this is how you guys play sports or musical instruments. So this how the dexterity comes. But in case of people who missing hand, they still have muscles, and they of course still have brains. So this technology tries to read the signals and artificially recover the hand, movement. So. So you put things like this on the arm. I don't have a time, but this is supposed to go around your residual arm. And whenever the actual amputee squeeze this by, remaining muscle, the sensor detects the signal, and it will, let you have your hand control again. So this is the technology I have. But first, I was, again, was a student, and I was in the engineering department. So this is what I did in my student ages. The focus was on technology. It was to, evolve the technology and write a paper and attend a technical conference. So I tried to make it faster, or try to have the control of multiple degree of freedom. So having individual finger control, or like to control the wrist and hand at the same time. So this is what I did in colleges. I also did a study at UC Berkeley, brain-machine interface. So basically, I put 200 electrodes inside monkey brain and try to classify what kind of movement the monkey is doing. And the charts on the right-hand side is, the left one is the actual data, and the right one is, a data that is inferred from actual brain activity. It somehow looks similar, but at the end of the day, I realized that this technology is still far from the practical use case. So, it's really difficult to recreate our dextral hand that you can play sports and play musical instruments. But along my study in college, I got to know lots of actual amputee, and from the conversation with them, I realized that the problem is not only the technology itself. There's an issue of the cost, because conventional hand like this costed 15,000 US dollars minimum. I mean, this technology has been on the market for more than 50 years, actually. A German company called Autobook commercialized it in 1960s, and it's really great. It helped a lot of people, but like, it's still not affordable technology for most of the people around the world. And another problem I realized was the design. Since the hand was so expensive, it was only a hand designed like actual skin color. So it was, kind of compensating. I don't want to say hide, but like compensating your missing piece. But as you wear glasses or wear shoes, I saw this could be a wearable device. It can be taken as a fashion. So this was two things I, want to focus after the study in college. And it was not only my concept that I got. It was also the whole infrastructure that supported me, because the way of manufacturing have changed dramatically in this past decade, I think. Before, I mean, there's lots of Japanese company who produce consumer electronics and cars, but those companies had this standard, like they got to have factory and customer service all in one company. So it involved lots of employees and lots of facilities. Also, it required lots of money, so you had to get millions of money from the bank. And also, of course, human resource is important. So manufacturing, making hardware could only happen in big company. But that's 20th century, I think. Nowadays, we have a 3D printer, Arduino for electronic modules. Also, we have smartphone that does amazing artificial intelligence, machine learning stuff. And it's really cheap. I mean, you can do this as a hobby. In terms of money, we now have a method called crowdfunding, which I really actually did. So this hand, the first thing I did was to raise on the crowdfunding campaign in Japan, and I raised 35,000 US dollars from 280 people who have both hands. So I don't have to directly sell to the user who really need it, but like I can find lots of supporters. So there's lots of sources for money too nowadays, and also people. Well, is of course important, but we have open sourcing kind of stuff. So this project is totally open source based. It's free. All the data is online. So many people around the world is now helping the development. So I'll show the summarized movie here. So this data has been on GitHub for almost 2 years. We disclosed our data in May 2015, so it's exactly 2 years now. And as you've seen, many people around the world are now not just copying, but customizing it. Like in case of Poland, we originally had only this data. I mean, it's adult size, it's big, and it's right hand. But guy, engineer in Poland from the city called Poznan made child-size version, which is 70% in size, and it was left hand. So things like this happen, and also in Germany, actual amputee who have been using the conventional hand for years made this hand by himself. So I think this is a really cool stuff of open source project. And just to let you know the numbers, it only costs 400 or 500 US dollars to make the whole system. The whole part is 3D printable. The computer part is Arduino Micro. I guess most of you know it's like only 20 bucks or things like that. The trick is it doesn't include any labor costs nor transportation costs. You just download it from website and you just make it by yourself. So that's the idea. And just to complement some another important point is that this is a picture I want to make by, say, 2025, so in 10 years. So I want to make hardware project as easy as cooking a meal. So for example, a kid, a girl missing a right hand from birth can make her original hand and add some, say, heart mark. She can customize it together with her mom. So I think hardware gonna be casual as this. Also, the idea of open sourcing is not just deliver it for free. It's also to involve lots of advancement in technology, even tiny advancement. Because in college, at an international conference, I saw that there's like really amazing technology in the world, but like most of the time, it's kept in academic field. It never get assembled, get together. So this is just a platform. It's the simplest platform, I think. But if you come up with small battery or a good gear, good motors, or like good AI system, you just can add on to this platform. So this is the idea for open source. And last but not least, I want to make this applicable to many kind of fields. So it's not just for people for missing hand, but like maybe elderly lady for have a weak leg but who still have dexterous hand can someday control robots in hazardous area or factory. So yeah, the technology-wise is nearly the same. So this is the idea I have for this project. And to get into this project, you just have to access to our GitHub page and a portal. You can find 3D CAD data. You can also find Arduino code, which is only 200 lines, so it's really simple. And also, we provide a forum that you can discuss or share your new idea. There are tutorial with lots of schematics so that you can make it really intuitively. Also, it's not only 3D printing parts. Like this is our 3D printing, but you still need some electronic parts and you have to buy it. But we also sell the package for this from Japan. And since it's open source, there's some people in Europe and US who are doing the similar kind of business. So this is the first step you should do. And well, it's not actually only us. Like there's lots of organization teams around the world doing similar thing. For example, in UK, there's a company called Open Bionics. They're also doing 3D printable open source bionic hand. And they're now collaborating with Disney, which have lots of content. So there's Iron Man version, there's Frozen versions, there's like Star Wars Luke version. So many kids are happy with this hand. And price-wise, it's, I think, kind of similar. In US, there's an organization called Enable. This is not motorized, so they don't use any motor. It's the wire they plug to their remaining joints. but it's much cheaper than even cheaper than this hand. It only costs like $20 to make the system, so it is spreading around the world. And of course, ICSI. So there's maybe you don't know, but there's a band, girls band called Baby Metal in Japan, and one professor in Japan made a Baby Metal version of HACKberry. So it's not only to add function, but it's also to add content and have fun together with actual users. So to kind of summarize, I think the impact of combining 3D printer and open source is twofold. One, you can localize technology immediately. You don't have to take care about customs. Of course, you have to take care eventually, but like to do that, you have to go through the regulations and all the stuff. But like it's really quick first step, I think. So to localization is one thing, and you also can customize to. Customize mean personalize. So you can spread out to each town, and you also can meet the expectation of each individual. So this is the potential of open sourcing, but there are many challenges we still have to overcome. So fact-based. I think there's two things I haven't achieved yet. One, it's spread out, but I'm not sure whether they are using it on daily basis or not. And two, it's not only giving them. You have to maintain the system because it's hardware, it breaks. So we don't have this ecosystem that you can repair it, things like that. And also another fact is that it's been copied, it's been spread out to the world, but it's not been evolved much yet. I mean, there became a child-sized version, but I want to expect more. I want to have more and more function on top of this platform. So I'm still not at a goal yet. And the reasons for after two years experience, I think there's 3 reasons that kind of obstructing our goal. One is, it's really manual processes and experiences you need. Like, for example, the hand. The hand part can be common, but the arm part is quite different because each person has different size and shape. Their residual arm is so different. So you have to involve a professional called prosthesis to have customized socket to actually fit it for daily use. And that is really difficult to digitalize and share. Also, it's not like copying and run the program. You still have to print it out. For this hand, it takes 1 day to print out, and also another half day, I'll say, to assemble it. So it's not like really instant compared with software project. And lastly, to have a hardware in a sustainable system, you have to take care of lots of things. For example, there needs, as I said, it requires players who can fix it, who can sell it, who can have a custom support. So all the functions that big company have is not here yet for this kind of individual sort of project. And also there's issues of regulation. For example, in US, you have to go through FDA approval of class 2, which is really high standard. It's almost impossible for an individual to go through FDA approval. And it's kind of gray zone still. In Japan, it's okay. It's not a medical device. It's welfare device more. So, but things will change, and most of the time, new technology get regulated at a certain time. So, I also have to talk with people in the government, and so this is the lessons I've learned on this project so far. For the last 5 minutes, I'm gonna talk about what I do now and what I wanna do from now on. So now I moved to the non-profit organization called Mission Arm Japan. This hand was created by my tech company, tech startup called ICSI, but now it's organized in non-profit because I want to make this whole ecosystem together with some actual users and all the people from medical field. So there's a, sorry, it's in Japanese, but there's, in the center, there's actual user, amputees. But around them, there's some engineer like me, there's medical professions, nurse, prosthesis, therapists, and also there's some company who can help us building this ecosystem. And around, there's lots of satellite projects. Not only this hand project, but like lots of hardware projects that can change the life of actual amputees. So here's some pictures. There are about 8 people here. All of them are missing hand, and they're playing with this hand together. They're playing with brick, and they're having fun. And from this kind of event, I can, as an engineer, I can have a direct feedback what is important for the next version, what is not, things like that. Also, I'm kind of teaching how to solder and how to program to people working in medical field, so that they can also feel them as a developer. And vice versa, I learned from prosthesis who actually made this customized socket. It's not only the 3D scan you do. You have to, some part you have to be tight, some part you have to be loose because it makes you some pain, but at the same time you have to be hold tightly. So it's not, you know, the digital posture you get.
もう回します。
So here's some outcomes. In this community, I'm still developing this project too. So on the left part, I'm now making the PCB circuit board smaller and smaller. So the latest one is the white one. On the right-hand side, this is not this HACKberry project itself, but this is another version of prosthesis. It's also 3D printable. So what he's saying is he's cognition. He doesn't have hand from birth, which means his natural length is till here. Like, but I first thought it should be this long as, you know, normal. I mean, not normal, not ordinary people. But he said it's more convenient if you have the function like plate at the natural length. So this is we call it body image hand. This is another conceptual hand. It doesn't have any joints. It's just the outlook you have. But like in special occasion like wedding or party, you can wear this, and at home you can use this as a vein. Or so this is how to say cosmetic hand version. So in this community, we're coming up with lots of ideas, lots of new functions like this. And it's not only the technology, we also have to share the knowledge too, because Mr. Morikawa is amputee. He lost his hand in 2013, but it took 2.5 years to get his hand from the in the conventional ecosystem, because lots of doctors know how to cut off the hand, but doesn't know what kind of technology we have on the market. So it took 1 year for him to persuade doctor to cut his hand off. Also, the government is really doing well. Like the insurance is getting better and better in Japan, but in the local town, they don't know it. So it took half a year to tell the officer in local government that he's eligible to get insurance. So sorry. So there's many things that, around the technology that we have to overcome. But since we have community, this lady from Peru working in Japan also had a severe car accident and she missed the hand. But since we have this community, she got access to doctor and amputee. So for her case, it only took 2 months to get an actual hand. And also there's thing like phantom pain, which is severe pain that is caused by the mismatch of brain image and the actual feedback. So this is another thing we have to cover, because no one around the world, no doctor knows how to cure phantom pain. So yeah, now this has been evolved as open hardware project, but I want to build on top of community, and now I'm trying to make a really strong platform so that this project can be sustainable and keep growing. Not rapid growth, but like keep growing sustainably. So, the last comment, but even still, I think the most important thing is to enjoy development as a developer. If we focus too much on user side, too much on problem, we lost our fun. So like we should not forget at first. First of all, it must be really fun as a developer. So this is my final comment, and thank you for listening.
Genta, many thanks for your awesome talk and this really awesome project. People have a lot of questions on it.
Thank you.
First question, how many people are using that?
You mean in Japan?
Or worldwide, in Japan and worldwide?
Well, okay, so in Japan, there are 5 people so far using it on daily basis, but they're still a test user. And I'm now checking what's gonna happen, what potential, potential bad thing you have.
Yeah.
Worldwide, I don't have exact track, but as I shown in the movie, it being copied, like basically around in each continent. So
you have 50,
yeah,
100?
I guess, yeah, about
So
50
you have
to
to also
100.
get-
Yes.
Which leads to the question, how durable is this arm? How long does it hold? I mean, when it does, 1 year, 2 year, what's your experience with it?
So this project has been here only 2 years, so I don't know.
They're holding 2 years.
It depends on how often you use it. Like each person has really different lifestyle. But I don't think it's gonna last for a year. So it breaks easily. If I drop down, I think it's gonna break. But good thing is it's 3D printable. So even you break it, you can just print it and fix it right away.
Perfect. It needs a battery. How long does it hold? I mean, can I go through the day, or do I have to recharge during the day?
Okay, good question. Thank you. So here's a battery on the arm part. This is a battery. It's a battery used for digital camera. So it's already sold project. It's safe. It's sold from, I guess, this is one is from Panasonic. So it lasts for, say, 6 hours. But you can recharge this, of course, but you also can have spare battery, so you can change it right away, too.
Thank you. One more question. Somebody was asking, and you have shown that people are born without an arm, and you have shown the short one. But can people learn to use a long one? Does that work, or you're working on that?
For people
who were born basically without
a hand. Yeah, definitely, most definitely. I mean, it only takes 1 minute for all the people to learn. Even even if you don't have hand from birth, you still have body image, and it is not just you missed a piece. It didn't grow much. So if I touch their arm, they actually have a really high resolution. Like I feel thumb, I feel palm. So once I put the sensor on their arm, they start to describe in body word that we know. This is the thumb, this is the index finger. So yeah, they can.
That's pretty awesome. Last question: have you worked on feedback to the body?
Not yet, and that's the one project I want to work on top of this platform. So if there's somebody good at sensory feedback, hardware, software, you're always welcome to join our community.
Great. Yeah. Thank you very much, Genta.
Thank you very much. Thank you.
Bye.